So we have a very basic example here of how to use functions, okay? Well, we're going to go to the next step, which is, in this case, writing functions, which are going to return a value, okay? So we're going to start very simple. We're going to write a function sum, which is going to return a value and take two parameters. Let's call them x and y. So always the same thing, okay? I'm working right now on the declaration of the function. I'm setting up the rules of the game, and there is one thing specific to function declaration, function signature. It's that you can, if you want, omit the name of the parameters, okay? After all that matters right now for my program is for the compiler to be able to say, for example, that if I have three integers, let's say a, b, and w, okay, when I call my function sum, w equals sum a and b, and I'm going to give them values, of course. When I do this, what matters for the compiler is to make sure that I spell the name of the function right, that the value which the function returns is used appropriately. So for example, here sum returns an int, and I'm assigning this int here to w, which is also an int. So that allows the compiler to do some type checking there, and everything is fine. Compiler makes sure that I have the right number of parameters, arguments, 2. That's exactly what I declared here. And the compiler makes sure that the type of each of the parameters matches what I was expecting. So for example, here I expect an int as first parameter, an int as second parameter. Guess what? A and b are both int. So the compiler can do its job. The compiler can say this function is called appropriately. Alright? So this is why you can omit the parameter's name. So is it a good idea, a bad idea? I don't want to enter that debate. Okay, I have my personal preferences. My personal preference is I like to have the name of the parameters in function prototypes. Why? Because except when we do like things trivial, like in these videos, just playing around with the language, generally the parameter names are going to be significant. Okay, they are going to have names that indicate what they are used for. So when you read the function prototype, it's good to have, a parameter which makes sense. For example, here we could have operand 1, operand 2. That would make immediately sense. I would see exactly what those parameters are supposed to do for this function. Okay? Alright, so again, we have our declaration up here. We have our function call here. Let me put some values to a, b, and I'm going to even set w to 0 before to call the function. And then I'm going to have to, of course, define the function. So here, the name of the parameters are not optional, okay, and you can easily understand why. If I don't name my parameters, well, then how am I going to use them in the body of the function? Okay, so every time I want to refer to parameter 1 and 2, of course, in the body of the function, I'm just using the name operand 1, operand 2 in this example. So what is my function doing? It's supposed to return a value. So sooner or later, I'm going to use a keyword return, okay, which is the same in C++, Java, and many different languages which borrow their syntax from the C family of language. And I'm going to return a value which is computed by an expression, operand 1, operand 2. And there you go. So let's compile this to remove syntactical issues. So far so good. And let's give it a little run. So it to start, hello world. Well, I called the function which is computing a sum, but I didn't display it on the screen, so that's not going to be really impressive as outcome. Let's fix that. The result is %d. %d means I want to display an integer value, and I specify my integer value here, which is w, the result of calling the function. Okay, that should be a little better. Let's compile again. Let's run. Hit the key to start. The result is 141, which is 99 plus 42. Still my hello world code there that I didn't remove, and pretty much my function is working. So the one thing that's important to notice here is that I am calling function outside of any, I would say, context. Okay, I do not have objects. The functions are not restricted to work only on object of a specific class. We are at a much lower level than the level of programming that you might be used to if you have been studying object-oriented programming with Java and C++, okay? So keep an eye always on those differences to help you make the fast transition from those languages to C, okay? Always think that we are at a much lower level here. Other thing really important to notice, okay, we learned to return values from functions, so this could be any of the data type that we have been talking about so far, okay? Int, double, long, whatever. The parameters could be of any of those data types as well. You of course don't have to have the same data type for all parameters, okay? That was just an example here where I needed 2 ints. And the last thing that you need to really remark here is that we did not modify any of the parameter. Okay, what do I mean by this? Well, if you are used to this terminology, you can pass parameters to methods or function by value or by reference. Rule number 1, in the C language, everything is passed by value. Okay, so if I would have put here the values, the literal 42 and 99, there would be no ambiguity. Okay, I am passing here expression, which are just literal, which evaluates into 42 and 99 respectively. These values are passed to the function. They are stored inside of parameters operand 1, operand 2, so it's clear that operand 1 and operand 2 represent a copy of the values that were given from the main, okay, when I invoked my function. So I just read values from those operands and I add them together and return the sum. Okay, so no confusion there. When I put variable names in my function call, some people get confused and think that, well, maybe operand 1 is the same thing as A, operand 2 is the same thing as B. Not at all. What happened here is that I have an expression. Instead of being just a literal value of data type int, this is a variable of data type int. A variable is evaluated into its value, so pretty much before the call is done, A is evaluated into 42. The value 42 is passed as first parameter. So when I enter the function sum and start running its code, I have here a local variable which is a parameter operand 1, which is fed the value 42. So I made a copy of the value 42 that was in the main stored in variable A, and I have it now in variable operand 1. Okay, that's exactly what happens. It is very common to represent this by doing what is called stack diagrams. The idea of a stack diagram is actually to represent what's happening as you are calling functions, what local variables are created, etc. And you should be familiar with this because this is something that is used, of course, also in object-oriented programming. Since some object-oriented programming introduction do not go at that level of detail, we are just going to summarize real quick what a stack diagram is and show you what's happening in this code and how you can trace it using stack diagrams.